Jai Hind. Today my topic of presentation is intelligent agents. In this particular lecture, we'll talk about the agents, what agents are, different definitions related to agents, the task environment that an agent assumes when it has to perform the task, different basic types of agents, and we will conclude our lecture with the learning agent. So, let us start with what an agent is. An agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. So, we will talk about agents. The agents are able to perceive the environment, and what they need to perceive the environment is the set of sensors. And what they do after perceiving from the environment, that is the performing actions in the environment. So, that we do with help of actuators. So, the agent will have sensors to perceive and actuators to act upon. So, let us try to understand the concept with help of few examples. So, one of my example is human agent. If I talk about human agent is one which is having some sensors. We all are aware of that what our sensors are: eyes, ears, skin, we smell. These are our sensing organs. So, these are our sensors. And when we see something, let me say I see something on the road, what I will do, I will pick it up and put it on the roadside. So, what I am able to sense, that is I am able to view using my eyes. So, my eyes are the sensors, and now what I am doing, I am picking it up and putting on some other place. So, what I am using, that is my hand. So, my hand is the actuator. So, hand, legs, mouth and other body parts are our actuator. So, we are talking here about a human agent. Let us understand the concept of agent with another example. So, the example is a robotic agent. If we talk about robot, the agent, robotic agent, so what we are having a robot. So, the robot will have a set of motors to do something. So, that is those are the actuators, and it will perceive the environment through one sensor, that is camera, another sensor, that is for example range finders. So, we are having different types of sensors with help of which the robotic agent will perceive the environment, and it will have some motors with which it will do the actions in the environment. Same way we can have software agent. The software agents will take the input through keyboard, mouse and all, and it will give the output on the screen. So, the agent is something which is able to perceive from the environment, and it is able to act upon the environment. So, sensors and actuators are the main components of any agent. So, let us visualize the idea. So, what is agent? This is the agent having sensors and actuators. This is the environment. The agent is interacting with the environment with help of the two things, the two main components. First is sensor. So, sensor is used to perceive the environment, that we call percepts. Agent percepts from the environment with help of sensors, and it do actions on the environment with help of actuators. So, this is the idea, this is the intuition behind an agent. Some related definition that we must know when we are talking about intelligent agent. First is percept. Percept is agent's perceptual input at any given instant. It is at any given instant. At any instant of time, what it perceives, what it takes as input, that is percept. And when we consider the complete history of everything the agent has ever perceived, that is the percept sequence. So, in sequence it will be maintained that what is perceived at one instant of time, then one instant before that, and so on. So it will contain the complete history. Then agent function, the agent perceives from the environment. So when it maps the perceived histories to action, means based on these perceiving, it do some actions on the environment, that is agent function. So it is a mapping from the perceived history to the action. Now, when this is the agent function, so what is agent program? Agent program runs on the physical architecture to produce the function f. So in case of this, what we will have architecture plus program both. Both will be combined to make the complete agent. So let us try to understand this with help of an example, that if I program a robot to pick something, so that is my program for picking. Now what is required for that? The robotic agent must have some arm, some hands to pick that up, so that we can run that program. That program is successful on that architecture only. If there are no hands, no arms, then it will not be useful to program for picking up something. So that is our agent. Agent consists of both the things, the programming, the program of the function which it is doing after perceiving the environment, and then the available hardware, the architecture. Let us try to understand an example, this concept with an example of a robot which is vacuum cleaner. So the world we are assuming here is, we are having a floor in which there are two tiles. So the floor is having only two tiles, tile A and tile B. So when we are having these two tiles, on this particular diagram in figure, we have shown dust here. So dust may be there or may not be. So this is our agent, this is our vacuum cleaner agent. Now what it can do, it will perceive the environment. So what it has to do, it has to clean the floor. So it needs to perceive the content. What are the contents here? That is dust. The vacuum cleaner will perceive that dust is there on the floor or not. If dust is there, then it has to clean it. So we are calling that, we are saying that it should perform the suck function. It will suck the dust. After cleaning this dust, what it should do? It should move in the environment. So it should be able to check where it is currently located, where it is currently present. It means we need one sensor to check dust is there or not, that is to check the contents, and the second point is the location. Why location is important? Because we are having this floor in which there are two tiles, and when we are having this floor, so when the agent is in tile A, it need to move to tile B. It means move right. If it is working in B tile, then what it has to do? It has to move left. So that are the possible function. So accordingly, it should be able to find out dust is there or not, and location, current location is A or current location is B. So we can see that our perceiving, our perceptual input will be the dust, tile, it is present in A and it is dirty. So both things have been perceived. Now based on this, it will do the action. What will be the action performed? It will be the sucking of, because dirt is there, and now what else it has to do? It has to move to right because it is in A, and now what is the total environment? From A we are having tile B on the right side. So to move to the right side, it needs to do the right operation. So this way we have to see what will be the perceiving according to the functions required, and based on that perceiving we will perform the actions. So this is one example of an agent which is our vacuum cleaner agent. Now rationality. The agent should be rational. When we are saying rational agent, what does it mean? What we mean by the rationality of an agent. Rational agent is the one that does the right thing based on what it can perceive and the actions it can perform. So, rationality of an agent depends on its perceptual power and its action performing power. So, what is the right action? It is the one that will cause the agent to be most successful. So, when now we are talking about the successful, most successful means success or not success. So, what does it mean? It means we should have some performance measure. Performance measure. So, what is performance measure? It is an objective criteria for success of an agent's behavior. What could be the age performance measure? Let us understand with help of few examples. If we take the example of vacuum cleaner agent, the performance measure could be the amount of dirt cleaned up, or how much time it has taken, or it could be how much electricity is consumed, or noise generated, the amount of noise generated or not. So, we are having different performance measure which are possible. So, the performance will be measured based on according different criteria. So, when we are talking about the rationality, we now need to take care of these performance measure and what it can perceive and what it can perform. For example, in the case of a robotic agent, we said that it is able to perceive that something is lying on the road. But if it is not having the architecture of hand, how will it pick up? So, the rationality cannot be related to picking up there, because the architecture is not allowing that. It is not able to perform that action. So, what is rational agent? For each possible percept sequence, a rational agent should select an action that is expected to maximize its performance measure, given the evidence provided by the percept sequence and whatever built-in knowledge the agent has. What it is able to perceive, based on that it will take actions, best actions, the right actions, and what it is trying to do, what it will try to do, it will try to maximize the performance measure. Now we'll talk about task, because when we are saying that agent will be there which will perceive something and will do. So, for what we are designing it? We are designing it for our tasks. It will be used to perform different tasks. For example, we considered the vacuum cleaner agent. So, when we are talking about now this task for which the intelligent agents are formed, so two things are to be studied here, to go through, to understand the task environment and the rational agent. What is the task environment actually? When we are creating, when we are designing, when we are making some agent, naturally we are having a problem in hand. So that is actually our task environment. The problem is the task environment. And what we have to solve, we have to do solution for the particular environment, particular problem. So for that we will make the rational agent, which are actually the solution. So let us take both the topics one by one. The first is the task environment. So for a task environment, we will study two things: how to specify it and what could be the different properties of the task environment. So I am taking first the specification of task environment. PEAS, PEAS, PEAS is used for the specification of any task environment. What is task environment? Our problem. So for that we will specify PEAS. Now let us understand what it is with help of an example. So PEAS is performance measure, environment, actuator and sensor. So in short, in using abbreviation we call it PEAS. PEAS for performance measure, E for environment, A for actuators and S for sensors. We have already discussed that performance measure could be the criteria based on what we are going to evaluate our agent. Environment is the problem where it is actually the solution, and it is having two components, actuators and sensors. Actuators to do action and sensors to sense the environment, to perceive from the environment. So we must first specify the setting for intelligent agent design using P's. So how to present it? Let us take an example of automated taxi driver. So what is my agent? My agent is automated taxi driver. When I'm talking about taxi driver, so what will be the performance measure? Naturally, the driving time, legal drive is there or not. So many things are there. Safety, how fast the drive is legal according to rules, comfortable, trip is comfortable or not, maximizing profit. So that are the performance measure. Now when we are having the taxi driver agent, what will be the environment? The environment will be the road. On road there may be pedestrians, there may be other traffic, heavy traffic, light traffic, and what else will be there? There will be customers also who will hire the taxi. So this is the environment which is to be where we will perceive, the taxi agent will perceive. Next is our actuators. What are our actuators? So our automated taxi driver will have the agent will have some actuators. What will be the actuators? The actuators are steering with help of which the taxi will be turned, accelerator, brake, horn. These are the actuators with which the taxi driver work in the environment, do actions in the environment. Now what are the sensors? The agent will take some input using perceptual inputs from the environment. So the sensors will be camera. To take the speed, it will be engine sensors, to see other engine things, and speedometer to measure the speed, to show the speed. That are the sensors it will have. So this is one example of an agent which is automated taxi driver. So this is the way the task environment will be specified. So we will talk about two things, the specification and then the properties. So here we have talked about the specification. Now second thing we will talk about is the properties. Properties of the environment. So we are having a problem, that is our task environment, where the agent needs to perform some task. So when we are having the environment, it may have different properties. So let us discuss few. First one is fully observable. So when we are saying fully observable, what the concept is? The agent sensors give it access to the complete state of the environment at each point in time. It means the agent is able to perceive everything which is happening in the environment. So that we are representing with help of the state. So when we are saying state, so we are taking that as the complete state, that is fully observable. Nothing is hidden from the agent. And if this is not a state, it means few things it is getting from the environment and few things are hidden, then we call the environment is partially observable. Second point, we can have deterministic or stochastic environment. So when we are having deterministic, it means we are able to find out the next state. As we are representing the environment with the states, so deterministic, the next state of the environment is completely determined by the current state and the action executed by the agent. It means the current state, then some action will be performed, and after doing some action, it will result in next state. So when we are able to find out, it is confirmed that this will be the next state, then it is deterministic. Otherwise, it is stochastic. The environment is stochastic if we are not able to deterministically find out the next state after doing action A in state S, which is my current state. If the environment is deterministic except from actions of other agent, what does it mean? It means when we are having this current state as S, do action A, and definitely the next state will be Sn from our side, and who can change this? Some other agent. It means we are having multiple agents in the environment. Then we call it strategic environment. So we can have fully observable or partially observable environment, or we can have deterministic or stochastic. Next is episodic. What is episodic task environment? When your task is such that we can divide it into parts. The agent experience is divided into atomic episodes. Each episode consists of agent perceiving and then performing a single action, and the choice of action in each episode depends only on that episode. It means the different episodes are taken from the work and everyone is working independently. The output of one is not taken by other part of the task, then it is called episodic. But if it depends, then we call it sequential. It means first episode will be performed, then second will be performed, and then third part will be performed. So our environment may be episodic or it can be sequential. Now, what else could be in our environment? It may be the state that the environment changes with time. If it doesn't change, then it is called static. If it changes, then we call it dynamic. So let us consider static. What is static environment? In static, the environment is unchanged while an agent is deliberating. The agent is doing its work and the environment is not changing. That is static. If the environment changes, then it is dynamic environment. The environment is semi-dynamic. It could be semi-dynamic if the environment itself doesn't change with the passage of time, but the agent changes that. The agent's performance code does. It depends on only the agent. The environment itself is not changing, then we say it is semi-dynamic. The environment may be discrete or continuous. If we are having a limited number of distinct actions and percept, then we call it discrete. If we cannot have limited, we are having unlimited number of percepts and actions possible, then it is continuous. And at last, an environment may have single agent or multi-agent. So if only one agent is working, then the environment is called single agent. If many agents are working, then it is called multi-agent. An agent operating by itself in an environment. So it depends, it is single agent or multi-agent. So when only one agent is working, then it is single agent. Otherwise, it will be multi-agent. Now, one more point is to be understood here. The multi-agent environment may be competitive or it may be cooperative. Okay, so cooperative and competitive. So when we are having more than one agent, more than one agents are there and they are competing to do the task, to solve the task, that is called competitive. And if they are cooperating with each other to do something, that is cooperative. Let us understand the concept with the help of an example. If a box is to be picked up and put at some place and one agent robot is not able to do, then we can use 2-3 agents. They will pick up the box and put at some other place. That is cooperative example. If we take the examples of games, in games one agent is working, one agent is doing some is playing the game, and in opposition other agent is playing. So they are in competition. So that is competitive multi-agent. So these are the possibilities that the environment may consider, may have. And now the most important point is, what is real world? Real world is toughest. So what it is? It is not fully observable. It is partially observable, stochastic, sequential, dynamic, always changes with time. There are not limited set of actions and percepts. There are continuously unlimited we get. So it is continuous and multi-agent. Number of things. There is not only one taxi agent in case of the traffic world. There are multiple taxi drivers. So that is our task environment. So we have studied about the specification using piece, and then we have studied different properties of the task environment. Now, second point is the agent. The task environment is the problem and the solution are agents. So now let us start with the agent, the second part, which are actually the solution. So firstly, we will discuss the basic types of agent and how the order is taken, that is in increasing generality, means more general, it will go on performing in more general way, the work will be performed. So the simplest one is simple reflex, then model based, then more general is goal based, and then more general is utility based. So let us take the example of different agents one by one. First one is simple reflex agent. Simple reflex agent is the simplest kind of agent. So when we are having this, what is the simplest kind of agent? Simplest means it will only see and then do something. So when I am saying that it will see and do, it means it is only considering the current percept. So it select action on the basis of current percept, what the agent just perceived, the current percept. It will not see the percept history, what was before that. Instantly it will see something and it will perform the action. So it select actions on the basis of current percept, ignoring the rest of the percept history. The simple reflex agents are generally condition action rule. These are based on conditions and actions. It means some action will be performed after a condition becomes true. So let us take the same example, that is of taxi driver agent. So if car in front brakes, if car in front is braking, then initiate braking. There is no other option. The driver has to put on that brakes. It has to initiate the brake, otherwise they will collide. It will collide with the taxi which is in front of this. So it is based on condition. If this happens, just do this. So this is current percept, and after this the action will be done. If car in front is braking, then initiate brake. So one condition became true, so that particular action will be performed. So this is condition action rule. Now because it is just taking the current percept in consideration and doing the actions according to that, so it has limited intelligence. It is not very intelligent system. It is just having the knowledge of few conditions and what to be done, what is to be done when some of these conditions become true. So that action is also specified, associated with the condition. So that is our agent which is having limited intelligence. Now what the point is it will it work well? So when it will work well, it can work well only if the environment is fully observable, because it just saw the car braking in front and then did the put on the brake. What will happen if there is some car behind? Okay, so car behind means something it just perceived before the brake, perceiving the brake from the car which is in front. Okay, so in that environment it will not work. It will work only when it is fully observable. Okay, so we are not always having in real world the fully observable environment. So it has problems when it works in partially observable environment. Let us understand the concept with the help of our vacuum cleaner example also. So if the vacuum cleaner example will have the dirt sensor only, so it will perceive the dust and dirt and it will suck it up. And if it is not having the location sensor, it will not be able to move from A to B or B to A. So when it will go on cleaning the same cell, same A or B tile, it will not do the cleaning in the other one, because it is not able to perceive the total environment. And whatever that example, toy example, it was having 2 cells. So what is the task of vacuum cleaner agent? To clean both the tiles. But because it is not able to sense the tile location, it is not able to move to the other one and clean that up also. So it creates problems in multi-agent systems also, where it can get stuck in infinite loops. We can have the concept of randomization to solve that problem up to some extent, but still it may occur. So this is our simple reflex agent. This is the block diagram with help of which can understand. This is our agent, this is the environment. Through sensors, it is sensing the environment and doing actions through actuators on the environment. Now what sensor is doing? In simple reflex, it is only perceiving the current situation. So that is the current percept. So what the world is like now, that it is perceiving. And based on that, it is taking, something happened. So something happened, based on that, some condition will become true. When this condition will become true, it will do the action. So which action is to be done, which is mentioned in the condition action rule. So based on that, it will do that action on the environment. This is our simple reflex agent. Next is our model reflex agent. In model reflex agent, we can work for the partially observable environment also. For this partially observable environment, what we need to keep track of, that is the internal state. So now let us understand this with concept of the with help of a diagram. So this is my model based reflex agent. Environment is there, sensors are there, actuators are there. Now with sensor, it will see what is the current percept, but with current percept, what it will note down, how the other environment is changing, other environment, what other things in the environment are changing. That may be changed because of other things or because of me, the current agent. The current agent will do some actions, some other agents will do the actions. So based on that, it will see which action to be performed. So the model reflex agent is not only taking the current percept, it is also taking the percept history, means what others are doing, based on that, what happened in the environment. That is model based reflex agent. More general is goal based agent. Here what we will have some sort of goal that will tell us what are the desirable situations. Need some sort of goal that describes situations that are desirable. So we want to be in that state. So our goal is to be in that state. So that is our goal based agent. So when we are having goal based agent, now what else we need to do? Now we cannot work on this condition is true, so we need to do this action. So that is not possible for us now. So what we need to do searching and planning. It means it have some more subfield attached to find the action sequence. So if we see it, we are having the current percept. This is current percept. This is how the world is changing because of me and because of other agent. What else is now? I am not given the condition and action rules. I am given a goal which is to be achieved. It means I need to plan for this. I need to plan to reach to the goal. So what it will be like if I do action A? So I am planning here, the agent is planning that what is to be done for this action, what action to be done to achieve it. So based on that, it will decide what the goal is, what the goal is. So based on the goal, it will decide what action to be performed, and that it will perform on the environment. This is our goal based agent. And the last one is utility based agent. Goal alone are not enough. What does it mean? Because a goal can be achieved or may not be achieved, but there may be a situation where we are more happy to achieve goal to some extent, or we achieve the goal through a more desirable path. So that is our utility based agent. When we are talking about utility, we will have utility function, and we need, what we want here, higher utility. What is our aim? Our aim is the higher utility that is desirable. Now, how this utility will be found? It will be found with the help of utility function. It maps a state onto a real number which describes the associated degree of happiness. So, what else we need to include in our agent? That is not goal now, it is utility. We will perceive the environment, what happened in the environment before, that is the current the percept history. This is current percept, this is percept history. Now my planning, what it will be like if I do action A. Now based on utility, I will find out if I do this action, how happy I will be. So what is my desired happiness? What is that? Higher utility. So we will try, the agent will try to maximize it. So based on that, it will find out the action that will be performed through actuators in the environment. So this is our utility based agent. This is the reference, Artificial Intelligence, a Modern Approach by Russell and Norwich. Thank you.